This is a lubricity tester, and with the help of the lubricity tester, we compare between variety of lubricants on the market and Polytron products. This lubricity tester has several parts. One part is the electrical motor, with the help of which the bearing race is rotating. Okay, here we have a bearing roller that is stationary. Now, when the bearing race is rotating and the roller is stationary, and we apply pressure between the roller and the race with the help of the torque wrench, then we get friction. The higher the load that we apply, the higher the friction. The load we apply with the help of this torque wrench, and these numbers represent the load that we apply between the race and the roller. As you can see, the race is rotating and the roller is stationary. And this is the worst case scenario in any mechanism, when one part is moving and another part is stationary. Now, when we start applying pressure between the race and the roller, the ampermeter will start moving upwards to higher numbers. The higher the friction, the higher the number it will show. And the difference between the new number and the zero friction number is actually representing the friction between the race and the roller. As you can see that the bearing roller and the bearing race are new and are completely polished, so there is no any damage on their surfaces. This is one of the best motor oils on the market today, Mobil 1, and we will test Mobil 1 against Polytron products, or we will see what happens to its performance when we add Polytron technology. As you can see, the race picks up the oil, so there's plenty of lubrication. Now we will see what happens when we apply 0 to 15 foot-pounds load, what happens to the friction. As you can see, this is 15 foot-pounds, and the ampermeter shows 10 amps. The friction that we had here was the difference between 10 amps and 7 amps, 3 amps. So 3 amps represent the friction between the roller and the race. Now let's see what happened to the friction surfaces, or the friction surface of the roller. Now, as you can see, that a major wear took place here, and the surface here is very rough. It's very important to point it out, because later on we will see what happens to the friction surface once we add Polytron. As we can see that Mobil 1 by itself could not protect the friction surface as soon as more load was added between the roller and the race. Now let's see what happens to the friction when we start adding Polytron MTC technology. Now we'll apply the same pressure of 15 foot-pound, and we'll see that the friction goes up to 10, and we'll see what happens once we add Polytron MTC technology. As you see, the friction went down almost to 7 amps, which is the internal friction of the lubricity tester. Now we apply higher loads and also pumping fluctuating loads. And we see that the ampermeter doesn't move, meaning that there's zero friction. Zero friction. Now we'll see what happened to the friction surface. As you can see, the friction surface is polished. Not only that the friction went down to zero, but also the friction surfaces that were rough became polished. Now we'll see what happens when we start applying pressure on a new surface. And we will clean the surface of the race from metal that was welded onto the race, because part of the friction is when metal from friction surfaces is welded onto a friction surface. The metal from the roller bearing was welded onto the race. Some of it. Can you also show the shavings in the oil? Now we will sand off the metal that was welded onto the race. Now we'll turn the roller to a new surface that was not worn out, and we will see what happens if we apply the same pressure onto a new surface with a mixture of MTC and Mobil 1. As you can see, the surface here is completely new. Okay, and we will see what happens to a friction surface which is completely new. We're using exactly the same mixture that we used before. Now let's apply the same pressure that we applied before, 15 foot-pounds, with the same mixture that we used before, and we'll see what happens to the friction. As you know, 7 amps represents no friction between the race and the roller. Okay, let's start applying the pressure. As you can see, we already applied 15 foot-pounds, and the ampermeter doesn't move. It means that there's no friction between the race and the roller. Now we will start pumping between 0 and 25 foot-pounds, which is much higher pressure and much worse type of load than we had before. And as you see, the ampermeter doesn't move. It means that there is zero friction. Now let's see what happened to the friction surfaces. That was before MTC was applied from the very beginning, and here MTC was used from the very beginning. The slight spot that you see here, it's actually a pressure spot, and it is more polished than the original surface. Now let's see what happened to the friction surface on the race. As you can see, there is a polished ring here on the race, which is more polished than the original surface. Polytron MTC, not only that it eliminated wear, it also polished the friction surfaces. And that's what is unique about Polytron technology.